This video is looking at how to balance redox reactions. So what you should already know is that oxidation is the loss of electrons and reduction is the gain of electrons. And here's an example of that, just to recap. So you've got magnesium reacting with oxygen to form magnesium oxide. And if we have a look at the reactions that are here, we can see that magnesium becomes magnesium ion and it loses 2 electrons. So this is the oxidation half reaction or half equation. Oxygen is O2 negative, so you can see here that O2 gas has had to gain 4 electrons to become O2 negative. So this is the reduction side of, or the reduction half equation. The other thing you should already know is about oxidation numbers and how to use oxidation numbers and allocate oxidation numbers. So oxidation, remember, is a loss of electrons, and it will show an increase in the oxidation number of an atom. Reduction is a gain of electrons, and that will show a decrease in the oxidation number of an atom. If any of this you're not familiar with, go back and have a check out of my last 2 videos again, which will, there's one on how to look at half equations and also the oxidation numbers. But if all of that's familiar to you, let's move on. So a half equation is not a true chemical equation. It only describes what's happening during reduction or oxidation, not both. And what we'll be doing in this video is showing you how to represent what's happening in both equations. Okay, so there's some steps in this, and what I've done is I've put this into point form. So the first part of what you'll be doing is balancing half equations, which we've already done a little bit of. So your first step is to write the half equations for both the reduction and oxidation reactions, showing the conjugate pairs. And by conjugate pairs, when I'm talking back here about the magnesium, the conjugate pair is the magnesium going to magnesium ion, oxygen going to oxide ions. The second step involves balancing all of the atoms except for oxygen and hydrogen. We'll be balancing those in the next 2 steps. The third step, balance the oxygen atoms by adding water. The fourth, balance the hydrogen atoms by adding hydrogen. The fifth step is to balance the charges by adding electrons. And the last step there is to add states. And this is all about balancing your half equations. So the first thing we're doing is writing the half equations for those conjugate pairs, then we're balancing all the atoms, then we balance oxygen by adding water, balance hydrogen atoms by adding hydrogen ion, and then we balance the charges by adding electrons. I'm going to run through this step by step with an example, and it'll make much more sense in a minute. Second bit is to write the overall redox equation. So what you need to do is ensure that there is an equal number of electrons that are used in reduction as are released in the oxidation half reaction. And then all you simply have to do is add the oxidation half equation to the reduction half equation. And when I'm saying add them together and balance out the electrons, this is what I'm talking about. And we did this in the half equation video. So here we needed to look at the fact that there was 2 electrons produced here by this oxidation reaction of copper. So we need to multiply the second half equation, or the reduction half equation, by 2 so that the number of electrons are equal. So we times the whole thing by 2, then these electrons cancel out. So you get the overall redox reaction looking like this. And all we've done by adding them is bringing what's on the left side of the arrows to here and what's on the right side of the arrows to here. But I'm going to run through that with an example now. So let's have a look at a question. When copper metal is placed in concentrated nitric acid, the brown gas nitrogen dioxide is formed and the solution turns green due to copper 2+ ions. write a balanced equation for this redox reaction. Okay, so the first thing we want to do is write the half equations for oxidation and reduction. We can tell from the question that copper metal is becoming copper 2 plus iron. So that's our first half equation there. It's the oxidation half equation. We know this two reasons. One, we can see that copper is becoming copper 2 plus, which means it has to have lost electrons. Oxidation is loss of electrons. The other way you can work it out is by using your oxidation numbers. So the second reaction, or half equation, is nitric acid going to nitrogen dioxide. And there's that reaction there. So it needs to be the reduction reaction. You can also work this out again by using your oxidation numbers. So we've got our two half equations. Step 2 is to balance all of the atoms except for hydrogen and oxygen. Okay, let's look at copper. We've got one copper on that side and one copper on that side. So that's already balanced. Reduction reaction, we've got one nitrogen and one nitrogen, they're balanced. And I've got, we don't worry about the oxygen because it's balancing all atoms except for hydrogen and oxygen. So, these are already balanced. So we can move on to step 3. So there's our two half equations. Third step is to balance the oxygen atoms by adding water. So copper goes to copper 2 plus. There are no oxygen atoms, so there's nothing to balance. Reduction reaction, we've got 3 oxygens on the left side, but only 2 oxygens on the right hand side, so we need to add water. We need one more oxygen, so we need to add one more water molecule. And there she is. Step 4, balance the hydrogen atoms by adding a H+. So, here's our copper again. There are no hydrogens, so there's nothing to balance. And this is the reaction that we've now got. Remember, we've just added this water on up here to balance out the oxygens. Now we need to balance out the hydrogens. So I've got 2 hydrogens on my right hand side. So I'm going to need to add 2 H pluses on my left hand side. 2 hydrogens and 2 hydrogens. So it's balanced. So step 5, balance the charges by adding electrons. So if we look, copper has gone from being 0 charge to being a 2 plus charge. So to balance that out, we need to add 2 electrons to this side. So now we've got 2 negatives, 2 positives, that equals 0, and a total of a 0 charge on the left hand side. Our reduction reaction, got 2 positive plus 1 negative equals 1 positive on this side. And on this side, we've got 0 and 0 charge. So we're going to need to add 1 electron onto the left-hand side. Now our charges on both sides are balanced. So now it's time to write the overall equation. So we need to balance electrons between the two half equations. So in the copper, we have 2 electrons. And in the reduction half equation, we only have 1 electron. So we need to multiply this reduction equation by 2. So that all changes to a 2 in front. And of course hydrogen, because there was already a 2, becomes a 4. So now we just need to add the two half equations together. So there's our two half equations, and all we're doing is adding what's on the left hand side of the equation, of both equations, to the left hand side of the equation. So I've just transcribed exactly what I see, and then what's on the right hand side of the equation down to the right hand side of the equation. So again, I've just transcribed everything or copied it down. Okay, last step is to cancel out the electrons. So I've got 2 electrons on this side and I've got 2 electrons on this side. So I just need to cancel those out. And again, just copy down what's left of the equation. And that's your final equation. What you can also do at this point, sometimes you'll have water on both sides or hydrogen ions on both sides, and you can cancel those out as well. But you'll see that when you do that in a few other examples. So that's pretty much all there is to it. Okay, so I've got question 3 here in your notes for you. Have a pause of the video. Have a go of writing balanced half equations for the following conversion. So pause it now and then I'll put up the answers. Okay, see how you went with those? Here are the answers. Okay, I will do some work solutions now, so if you're interested in that, have a look. Otherwise, fast forward the next couple of minutes and I will go on to the next question. Okay, so the first one we have got here is bromine to bromine. Now we need to balance the bromine. So we've got 1 on this side, 2 on this side, so I need to put a 2 on this side. And then we balance the oxygens, there aren't any, the hydrogens, there aren't any, and then we need to balance the charges. So I've got 2 negative on this side, so I need 2 negative electrons on the other side. I've now got 2 negative charge on this side and a 2 negative charge on this side. So nitrate to nitrogen dioxide. First thing I need to do is balance the nitrogens. Nitrogens are balanced, there's 1 on both sides. Oxygens need to be balanced. I've got 3 on this side, I've got 2 on this side, so I need to add a water. Hydrogens need to be balanced. I've got 2 hydrogens on this side, so I'm going to need to add 2H positive on this side, and now I just need to balance the charges. So I've got 0 charge on this side, and here I've got 2 positive and 1 negative. So I'm going to need to add 1 electron on this side. Now I've got 2 negative and 2 positive, which equals 0. Last but not least, I've got nitrate going to nitrous oxide. Again, nitrogen, balance the atoms, 1 nitrogen, 2 nitrogen, so I need to put a 2 in front of the nitrate. Balance the oxygens. I've now got 6 oxygens on this side and I've got 1 oxygen on this side, so I'm going to need to add 5 water molecules to this side. Now I've got 10 hydrogens on this side, so I need to add 10 hydrogens here. And now I've just got to add electrons. So what I've got is 10 positive, 2 negative. That makes 8 positive. And on this side I've got no charge. So I've got 8 positive, so I'm going to need to add 8 electrons. 8 negative plus 10 positive equals 2 positive with 2 negative, which equals 0. So that's balanced. Okay. So our next example here that we want to have a look at. So this is question 5 in your notes. Balance the following equations using the half equation method. So this is an example that I want to show you. So the first thing you need to do here is to identify your half equations. How are we going to do that? Using oxidation numbers. So let's have a look at iodine has got an oxidation number of 0, and sulfur, they're plain atoms, they've both got oxidation numbers of 0s. Now we need to remember our rules. Remember that all ions have an oxidation number of their charge, so iodide will be -1. Hydrogen always has a +1. There's 2 hydrogens, that's 2 positive, so sulfur is going to have an oxidation number of -2. Now we need to look at what's increased in oxidation number and what's decreased. So if we have a look here, iodide has decreased in oxidation number, so this must be the reduction half equation. The other one has to be the oxidation half equation, and you can see here it is because it's increased, sulfur is increased in oxidation number. So your oxidation half equation is this, and your reduction half equation is this here. Great. We need to just go through with our balancing now. So first thing you need to do is balance the sulfurs here. They're already balanced. Sorry, I've gotten ahead of myself. Now we need to balance the water, or the oxygens with water. There are no oxygens, so there's no need to do that. So last but not least, we need to balance the hydrogens. There's 2 on this side, so we throw in 2 hydrogen ions on this side. Now it's just a case of balancing the charges. 0 charge on this side, and I've got a 2 positive charge on this side, so I'm going to need to add 2 electrons. Okay, so let's look at our iodine here. Iodine is going to iodide. There's 2 iodines on this side, so I need to make 2 iodines on this side. Next thing I need to balance is my oxygens. There aren't any. Then my hydrogens, there aren't any, so I just need to balance my charges using electrons. 0 charge, 2 minus charge, so I need to add 2 electrons to this side. Great, so now I've got 2 electrons on this side and 2 negative charge on this side, so that's balanced. So my last step here is to add those equations together. First thing I need to do when I do that is to make sure that the number of electrons are even. This is an easy one because yes, they are even. Otherwise I would have to multiply one of the equations to make those electrons even. So I just add these 2 together now, and I can get rid of those electrons since they balance out. So I end up with a final equation of iodine plus dihydrogen sulfide goes to my 2 iodide ions plus sulfur plus my 2 hydrogens from here. Okay, got an example for you to have a go at here. Again, I'm going to let you pause the video, answer the question, I'll put up the answer, and then I will run through the answer for you. Okay, so here's the answer. And I'll work through that answer now for you. So the first thing we need to do with this is allocate oxidation numbers, so we can figure out what our oxidation and what our reduction half equations are. So I always start with the easy ones that we know. We know that sulfur will be 0 because it is just a plain atom. Okay. Oxygen is always -2 unless it's a peroxide, and we know that hydrogen is +1. Okay, so now we can work out the metals. Nitrogen needs to be a +2 here to balance out this oxygen. Sulfur here needs to be +1 times 2 is +2, so it needs to be -2. And here we have oxygen -2, which is -6. There's a minus there already, so that nitrogen needs to be +5. So if we have a look what's increasing and what's decreasing, sulfur is increasing, so that needs to be our oxidation reaction. So I'll just leave myself a bit of space. Goes to S solid. Okay, and our reduction half equation must be aqueous gas. Excellent. Okay, now that we know that, we just need to go through how to balance them. So, balance atoms, sulfur and sulfur is balanced. No oxygen, so balance the hydrogen by adding 2 hydrogens to this side. Now we need to balance charge, so I've got 0 charge on this side, I've got 2 plus on this side, so I need to add 2 electrons to this side. This equation here, I've got nitrogens are balanced, 1 nitrogen each. I have 3 oxygens on this side and only 1 on this side, so I'm going to have to add 2 waters. To balance out the hydrogen now, I've got 2 waters on this side, so I'm going to need to add 4 hydrogens on this side. And now I need to balance out the charges. So I've got 4 positive and 1 negative. That makes 3 positive. This side's got a 0 charge, so I'm going to need to add 3 electrons to this side. Okay, so our next step is to make sure that these electrons here are even so that we can add those 2 half equations together. So I'm going to need to multiply this equation by 3 and this equation by 2. And I might just swap coloured pens to make it a little bit clearer for you. So that will become 3, 3, 6 and 6. And here we will have 2, 8, 6, 2 and 4. Now that we've done that, I can cancel out my electrons and add those 2 equations together. Now that I've done that, I can cancel out our electrons and add those 2 half equations together. And here I can also decrease the number of hydrogens. I've got 8 on this side and I've got 6 on this side, so I can make this 2 hydrogens. Don't forget your states. Plus 2NO gas plus 4H2O liquid.